Hello everyone, it's Mrs. Ruscio again, and you are watching Solving Quadratics by Factoring Day 2 Notes. In this video, we're just going to build off of what we talked about on Day 1. We're going to be writing quadratic equations in standard form if we need to, because sometimes it might not be set equal to 0, and we learned that that's a real big deal when we're trying to find the zeros. We have to set it equal to 0. And we're going to find the solutions, roots, zeros, algebraically by factoring, and sometimes we're going to do it by factoring completely. So we might have to take some knowledge from Unit 5 and apply it to what we are doing today. So number 1, I'm going to dive right in. We are going to find the zeros of this quadratic algebraically. And let's use these little thought bubble things, I don't even know, flags. Sometimes we need to factor completely. So we're going to take a look at this. And I think some of you are like, well, Mrs. Ruscio, let's set it equal to 0. And I know that there's some friends out there who really hate having the 0 on the right-hand side. So let's just move it on the left-hand side so people don't get stressed. Okay? So here's our first step. We're going to make g of x, make that 0. Then I'm noticing that there is a greatest common factor of 2. You got it. So we're going to factor out a 2. If I do that, I'm left with x squared plus 5x minus 14. Now, this is where the box comes into play. Some of you might say, I don't need the box anymore. I'm going to step away from it, but if you want to show the box off to the side to factor this piece right here, there is nothing stopping you from doing that. But when I factor in my brain, I'm trying to find two numbers that multiply to negative 14 but add to 5. That's negative 2 and positive 7. Okay, we are going to do exactly what we did yesterday and take each one of the factors and set them equal to 0. Only this case we have something weird happening. 2 equals 0. What? That doesn't make sense. So I'm going to throw that away. X plus 7 is equal to 0. That just means the 0 root solution is happening at x equals negative 7. Remember, the inside lies. X equals 2. Oh my gosh, guys, this is why the inside lies to us, because it's tied to quadratic equations. Isn't that amazing? In this case, x equals 2. Okay, if you graph this on a calculator, remember, you can see and check your work. Oh, hey, there's a 0 at negative 7. Oh, hey, there's a 0 solution root at 2. We did this correctly. We are happy. All right, number 2, let's read that little flag flying over here. It says sometimes the equation isn't set equal to 0 or y equals 0. So we need to set it equal to 0 somehow, some way, where it's not as easy as literally plopping 0 in for y. But we want to make sure that x squared is positive. Well, it looks to me that we got to do some moving around. So I am going to leave my 5x squared put, but I'm going to move everything from my right side of the equation and move it to my left side. And the reason is, if I do that, I get a positive x squared, which is what I was going for. That minus 48 needs to move over as well. I'm going to do that, but I'm going to squish it in over here. He doesn't have any like terms, no friends, so we have to throw him down at the end. So tragic. 5x squared minus 4x squared is 1x squared. And instead of writing 1x squared, are you guys okay if I just write it as x squared? I feel like it's easier to see when we're factoring. Minus 2x, he had nobody to combine with, so we're just bringing him down for the ride. Minus 48. Equals, well, that became 0, that became 0. That equals 0, and we now can factor. So I am going to use my box, or I'm going to do the box in my brain, and I'm going to try to find two numbers that multiply to negative 48. So 1 and 48, I don't know, 2 and 24. 8 and 6. I think that's it. 6 times 8 is 48. But I need a negative 48. So negative 8 and positive 6 because my little corner of the box would have to add to that negative 2x. If you are not following me without showing the box, please, for the love of math, put the box down and factor, because many of you, I think all of you, are factoring wizards at this point. All right, you know the drill. X minus 8 equals 0, and x plus 6 equals 0. The inside lies to us. X equals 8, because we added 8 to both sides, and x equals negative 6. Dun, 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 dun. That was so fun. All right, we have one more to do. Okay, solve algebraically for y. Well, this is confusing because we usually don't solve for y, but it's written like a quadratic. So sometimes, let's look at this flag, sometimes we have to distribute to see the function is a quadratic. Oh yeah, look at that. This doesn't even look like a quadratic right now. Well, we probably need to do some undoing. Ha-ha. Y times y is y squared. There she is. All right. Minus, or is equal to 16 minus 1. Y. All right, we want to keep the squared term positive like we talked about in the last one. So let's bring everything over to the left side again. All right, I'm going to subtract 16 from both sides. Well, I got to squeeze that in there. And then I got to add 1y to both sides. You could sort if you wanted to. I'm cool with that as well. But either way, we are going to end up getting y squared plus 6y minus 16 is equal to, bam, bam, thank you, ma'am, 0. All right, factoring. No GCF. We're going to set up the box. And I'm doing the box in my brain. I want two numbers that multiply to 16, but add to 6. Ooh, that's 8 and 2, I think. Or 8 and negative 2? Yeah, because 8 times negative 2 is negative 16. 8 plus a negative 2 is 6. You know the drill from here. This is like a piece of cake at this point. So we just added a couple extra layers on today. I got y is equal to negative 8. And I'm getting y is equal to 2. Now, some of you might say, Mrs. Ruscio, if I graph this, what do I type in the calculator? You would actually have to type in x's here, because otherwise the calculator wouldn't know what to do. All right, I hope you had fun learning more about factoring. Well, solving by I almost said quacking. Solving quadratics by factoring. Okay, peace.